Hello everyone. Today we'll be solving the problem New Year Domino. Right. So New Year Domino. Right. So this was asked run. So basically goodbye 2014. Right. So basically we'll be solving this problem New Year Domino. Right. So what the question states here, you can just go through the question. It will be easier for us to understand. I'll just summarize the question so that it will be easier for us to understand. So you can just go through the question. It is easy to understand basically, right? So now what the question states here, just give me a second, 1 second. We are given n vertical dominoes. So let me give you here. We are given n vertical dominoes with a height li at x position, right? So we have been given n vertical dominoes with a height l at x position p x position p, right? So at x position p at x position p, right? Aligned on the x axis if you push any domino, if you push any domino, it falls to the right and can hit the next if it intersects. Only if it intersects, then uh, if we push any domino, it falls to the right and can hit the next if it intersects. Only if it intersects, it will hit the next, right? So when one domino hits another, the second domino also falls similarly, creating the chain reaction. So if another domino hits the next one, then it intersects the second one, right? So it forms the chain reaction and goes on. Right? So that's what they have given in the question. So we are given q queries, each asking, if we push the x domain, how much minimum height increase is needed. Nothing but how much cost. Basically, how much minimum height increase is needed means the cost they are asking, right? So that the white domino also falls. The dominoes are placed in increasing p. Right? So we need to find the cost here. Means we are given q queries. We know that we are given q queries here, each asking, if we push the x domino, if we push x domino means xj, I'll consider here x domino, how much minimum height increase is needed. That's what we need to find. How much minimum height is needed, nothing but the cost, so that white domino also falls. Right? So how much height is needed, or the cost is needed for the x domino to fall, so that white domino also falls. Right? That is what we need to find here. The dominoes are placed in the increasing pi. So let me read this one again. Let's try to understand this one again so that it will be easier for us to solve the problem further, right? So we are given n dominoes. We are given n vertical dominoes with a height li, basically, at the x position, p. So this is fine on the x-axis, right? On the x-axis. If we push any domino, it falls to the right and can hit the another domino, or and can hit the next if it intersects. Then it intersects, right? If it hits the another one, then it intersects, right? When one domino hits another, the second domino also falls. When one domino hits another, the second domino also falls similarly, creating the chain reaction. So this is the chain reaction intersection I have shown, right? This creates the chain reaction. What we need to find here, we have been given q queries. Each asking, if we push the xth domino, how much minimum height increase is needed. Nothing but they're speaking of the cost here. If we push the x domino, how much minimum height increase is needed, so that white domino also falls. This one I'm speaking of, so that white domino also falls. The dominoes are placed in increasing p. This one I'm speaking of, the dominoes are placed in increasing p, right? So this is what the question state. in simple terms, we have to find the minimum height increase that is needed for the white domino to fall, basically, so that x domino to fall, so that white domino also falls, minimum height that is needed for the x domino to fall, so that height this one white domino also falls, right? So that we need to calculate, and they have given the dominoes are placed in increasing pi, right? Easy to understand. So let's come to the input output part here. Let's come to the input output part here. So here we have been given input, we have been given six inputs here, right? So this one domino 1 at the position 1, basically, and length 5, and length 5, right? Domino 1 at the position 1 and length 5, domino 2 at the position 3 and length 3, right? So this one same goes with this one as well. Domino 3 at position 4, domino 3 at position 4 and the length 4, domino 4 at length position 9 and length 2, this one domino 5 at position 10, length 1, domino 6 at position 12 and length 1. This one I'm speaking of total 6 inputs. The first this one what they have given, this indicates that we have been given 6 dominoes, right? So here this falls till 6, so this we will discuss this one later. For now, you just remember this one. We have been given six inputs, nothing but domino 1 at position 1, length 1, domino 2 at position 3, length 3. Same goes with the next four. These four, what it represents here, we have been given four queries. Accordingly with the question, they have said that we are given q queries, right? So here in this case, we have been given four queries. Q is nothing but 4 here. Right? So this one, this query 1, this is nothing but the push 1 want 2 to fall. This is nothing but the push 2 wants 4 to fall, and this is nothing but again push 2 want 5 to fall, and this one is nothing but the push 2 again want 6 to fall, the right side, right? So this one, these are the queries. Just remember these are the queries, so when we discuss the approach you will get to know the things better, right? So the output that we need to get here is nothing but the minimum height increase that is needed for the xth domino to fall, so that white domino also falls, is 0 1 1 and 2, 0 1 1 and 2. Just keep this in mind, man. Simple one, right? Simple one. But the only thing here is the constraints are very tight. Here. The question is simple. The constraints they have given are somewhat tight, right? So let's see the approach. Followed by the complexities, and then let's write the code. Let's see the approach followed by the complexities, and then let's write the code. First, as usual, let's see the approach. So here I have considered the same first example that they have given in the question, right? So we have six inputs, the same thing here. So here we discussed this one already. We have discussed this part already. We have been given four queries as well. So we need to get the output 0 1 1 2, right? So let's see the step-by-step explanation. Let's move on with the step-by-step explanation. So here we have considered the same input, right? So here this one 1 5 indicates that domino 1 is at the position 1, length 5. Domino this one position 1, length 5. Domino 2 at the position 3, length 3. Same goes with 4 4 9 2 10 1 12 1. 6 indicates that we have been given 6 dominoes. Right? So here I hope this one is completely fine, man. This falls till 6. This falls till 6. This falls till 8. This one till 11. This one till 11, and this one till 13. This one till 13. When we sum up this one, basically falls till 6 months. Here we are doing 5 plus 1. Next we are doing 3 plus 3. Next we are doing 4 plus 4. Next we are doing 9 plus 2. Next we are doing 10 plus 1 here. The final one is 12 plus 1. 12 plus 1. See here, 3 plus 3 will lead us to the 6. 4 plus 4 will lead us to the 8. This one 9 plus 2 will lead us to the 11. 10 plus 1 will lead us to the 11 again. 12 plus 1 will lead us to the 13. will lead us to the 13, right? Domino 1 at the position 1, length 5, it falls till 6, it falls till 6. So 3 plus 3, again this will fall to the 6 as well. Domino 2 at the position 3 and length 3, 6. Same goes with the other 4. Now we have been given 4 queries as well. 4 queries. This is query 1. You can just represent it this one by query 1, query 2, query 3, query 4. So we are pushing 1. We are pushing this one 1. We are pushing 2. We are pushing 2. We are pushing 2 again. So we are pushing this second one, second domino thrice, thrice, right? Push 2, push 2, push 2. We are pushing 1 first, want 2 to fall because the right side we have the 2 value 2. We are right side we are having 4, we want 4 to fall, we want 5 to fall, we want 6 to fall. So we are pushing 1, want 2 to fall. We are pushing 2, want 4 to fall. We are pushing 2 again, want 5 to fall. We are pushing 2 again, we want 6 to fall. We want 6 to fall, right? I hope this part is completely clear, man. I hope this part is completely clear, right? So now I hope the input output part is completely clear, because this is important for the further steps, right? So first what we will be doing, we will be going with the pre-processing. Before this one, let me tell you one thing. We will be making use of the segment tree. As the constraints are tight, we'll be going with the segment tree, right? We'll be going with the segment tree. Also we have been given queries, right? So whenever we are handling queries, so it is better to go with the this one, segment tree or the Fenwick trees, right? Range query problems usually will be going with the this one itself, right? Segment tree or the bit Fenwick tree, right? Also we can go with the sparse table. Also we can go with the sparse table. Usually sparse table range minimum queries, we will be solving with the sparse table. So this is not the range minimum query problem. So either we can go with the segment tree or the this one, bit Fenwick tree, right? Or the binary index tree. So I prefer to go with the segment tree, so I went with the segment tree. You can also solve with the BIT or the Fenwick tree, right? So here we'll be making use of the segment tree along with the greedy approach and the binary uplifting. Along with the greedy approach and the binary uplifting. Mainly, we'll be going with the segment tree for this particular problem, right? So here, let me move on with the main step. Let's start. So for first step here would be pre-processing step. We will be pre-processing six. We have been given 6 dominoes, right? So we have been given 6 dominoes. So we will be pre-processing from right to left. We will be pre-processing from right to left. Means here first, uh, I we will start from 0. This is reverse iteration, right? I we will start from 0. So this will be 0, 1, 2, 3, 4, 5, 6, right? So we will be going with the reverse iteration. So we will be starting from 5. Nothing but we will be considering domino 6. Nothing but, again I'm telling, this is reverse iteration. We are going from right to left, not left to right. If we have went from left to right, we would have considered first I equals 0 rather than I equals 5, right? So don't get confused here. What we will do first, we will pre-compute, or we pre-compute iterated value of the result. This is nothing but the result of I. This is used to store the result, right? So what we are storing, we have to store the minimum cost for domino I to cause a chain reaction all the way to the end. So I have already explained, right? Whenever the domino hits the another domino, it hits to the next one only if it intersects. That they have given in the question, right? So if it hits the next one, then it quite obviously intersects. So that's what we need to find. The minimum cost for the domino I to cause a chain reaction. The minimum cost for the domino I to cause a chain reaction, that we need to calculate, right? Uh, all the way to the end. First, what we'll do, we will consider I equals 5, nothing but domino 6. Already this is the last domino. Result of 5 is 0. Result of 5, uh, because I equals 5 we have been given, so result of 5 is 0 here. Just remember this one, first one, I equals 5, for the domino 6, result of 5 is 0. Next, let's move on with the I equals 4 next step. So here we are calculating for the domino 5, right? So it can fall to 11. It can fall to 11. See here, somewhere I have showed the same thing here. It can fall, this one domino 5 we are considering with 10 and 1, means it can fall till 11, right? So let me remove this one second. Just give me a second. So this one, let me remove this green spot so that you'll understand. Just give me a second, man. This is not working, I don't know why. Yeah, Just give me a second. 1 second. So let me do one thing. Let me write the six dominoes here, man. We have six. First thing is 1 5 1 5 uh 3 3 4 4 9 2. 1 second. 3 3 4 4 9 2. The last two are uh here it this one 10 1 12 1. 10 1 12 1, right? So here for the fourth domino means we have already considered this one domino 6. This is over. Now we have to consider 10 and 1. 10 and 1 means it can fall up to 11. 10 plus 1, right? It can fall up to 11. This can fall up to 13. Result of 5 we have already got 0 here. So this one it can fall up to 11. So domino 6 is at 12. Domino 6, this one is at 12, right? So this is not reached. As it is at 12, it can fall only up to 11, right? Domino 5 can fall up to only 11, so this is not reached. Need one extra unit to reach. So cost is 12 minus 11, nothing but 1. Cost is 12 minus 1, nothing but 11. Here we have 12. Here we have 12. 12 comma 1 is this one. 12 comma 1 we have nothing but 13, right? So here we have 10 plus 1, nothing but 11. Nothing but 11. So here domino 6 is at the 12. Result of 5 we have got 0, right? Result of 5 we have got 0. Now we are calculating result 4. So domino 6 is at the 12. Starting number, this is 12, right? So this is not reached as we have only 11 for the domino 5. As we have only 11 for the domino 5, right? So we need one extra unit to reach, nothing but 12 minus 11 is 1, right? So result of 4 we have got 1 here. So this is 1. Let me give here, result is 1. Next we have 9 2, 9 and 2, right? So this will lead to 11 as well. This will lead to 11 as well. Let's carry on with the further steps. I we have 3. It will fall this one falls to 9 plus 2, nothing but we are considering domino 4 here. 9 plus 2, nothing but 11. Domino 5 is at 10 comma 6 at 12. Domino 5 is at 10 comma 6, this one at 12 basically. So here see domino 6 again, we are considering domino 6, right? So this one is at 12, is at 12. So now 10 is less than 11. 10 is less than or equal to 11. Yes, it is less than 11, right? So 5 is reached. We will go with result of 4 equals 1. We have already went with result of 4 equals 1, and 12 is greater than 11, so 6 is not reached. So 6 is not reached. So result of 3 and result of 4 both we will be giving 5. So we have to add the extra unit 1 here, right? So we have to add the extra unit 1. So result of 3 equals result of 4, both will be going for 1. Now let's move on with the domino 3 here. Let's move on with the domino 3. It falls with this one. 4 and 4 we have, right? 4 comma 4 we have, somewhere I have written this one. See, 8 we have here. 8 we have here, right? So 8 we have here. So what I'll do, domino 4 is at 9. Domino 4 is at 9. See here, domino 0, this one, 1 2 3 4, 9 and 2 we have here. 9 and 2. For the 4 we have 9 and 2, right? So domino 4 we have 9 here, the initial value. Domino 4 we have 9 here. So this is not touched. 8 we have, and the domino 4 we have 9. And again we have to calculate the cost, right? Cost, it is not reached or it is not touched. So 9 minus 8 will be going, we have to go with 1. We need one extra unit here. So result of 3 is 1. So total is this one, result of 3 plus this one, result of 2, result of 3 we got 1, and result of 2 also we got 1. 1 plus 1 will lead to 2 basically. Result of 2 is 2. We will be storing this one in the paradigm 0 and 2, nothing but this will lead to 3. 2 plus 1 totally 2 plus 1, this will, we will be going with paradigm this one par 0 and 2, this will lead to 3 basically, right? So now the result of 3 we got 1, result of 2 we got 3, result of 3 we got 1, result of 2 we got here as 3, result of 2 we got here 2, uh, par paradigm we have considered, right? This one 0 0 2, this will be 3 basically. This will be 1, this will be 2, right? So let me write it here so that will not get confused later. So this one will be 0 1 1 again, so this one will be 2. We are left with last two basically. Let's see, we are left with last two. So when I equals 1, we are considering the domino 2, right? So this falls till 3 plus 3 because we have 3 comma 3, we have 3 comma 3, and at the domino 3 we have the first number 4 4 comma 4 we have, right? So we have 3 comma 3 or 3 comma 2, 3 comma 3 itself we have. This one for the domino 3 we have 4 comma 4, and for the domino 2 we have 3 comma 3 here, right? So now we have 3 comma 3 and 4 comma 4, so this is reachable, this is reachable, right? So we will be popping 2 from the stack, we will be popping 2 from the stack. See here, we have 6, and domino of domino 3 we have this one 4. 4 is less than 6, right? 4 is less than or equal to 6, 4 is less than 6, so this is reachable directly. So what we will do, other two we are left with the 2, right? 6 we have, 6 we have, here we have 4, so we will pop 2 from the stack. We will consider only result of 2 equals 2. We'll pop 2 from the stack because 6 minus 4 will be 2, and we'll pop that 2 value from the stack, and result of 2 will be 2, and result of 1 will be result of 2 equals result of 1, nothing but it will be 2 itself. It will be 2 itself because it is directly reachable, will not be adding. So here result of 2 equals result of 1, that will be 2 itself, right? So here we got the value 2 for this one, we got the value 2 for domino 2, domino 2. So this will lead to 6, and the value will be 2, right? So this one again, 5 plus 1 we have 6. Let's see what value we get for this one, right? What value we get for this one. So I equals 0, nothing but the first domino, the last one, as we are going with the reverse iteration here. So this falls with uh, we have 1 and 5, right? So this falls for 6. Domino at the domino 2 we have the first value, we have the domino 2 3 comma 3, the first value is 3 here. So domino 2 has 3, and here this the sum is 6. Is 3 less than or equal to 6? We will check. Yes, 3 is less than 6, right? 3 is less than 6, so this is reachable directly. Again, similar to the previous one, this is reachable directly. So we will pop 1, we will not be popping 3, instead we will be popping this one, popping 1. Basically we are going with the domino 1, right? So sorry, here I got confused. I think I said 6 minus 4 equals 2, right? So we are going with the domino 2 basically, that is the reason we are popping 2. Sorry, I really got confused here. This one we are popping 1, we are popping 1 because we are going with the domino 1 from the stack. So result of 1 will be equivalent to 2, and result of 1 we can just write it in this way, result of 1 equals result of 0 equals 2, right? So here we got the value 2. Let me write this one here. So this one will be 2 as well. So the value that we got here is 0 comma 1 comma 1 uh, 2 comma 2 comma 2, right? So 0 double 1 triple 2, 0 double 1 triple 2 is the value that we got, right? So here result after pre-processing is triple two double one zero. So we went with the reverse iteration. We got 0 double 1 uh, 2 2 2 from the end. We got this one, right? So when we reverse this one, we get triple two double one double one zero. So this is uh, this is the pre-processing step. This is the pre-processing step. We saw this one step by step iterations we saw, right? Right. So here the output that we got here is triple two double one zero, triple two double one zero. The output after pre-processing we got again triple two double one zero, triple two double one zero. I hope the pre-processing part is completely clear, man. We are done with the this one pre-processing. Pre-processing itself is somewhat difficult, you can say. It's not difficult, but basically we have discussed all the iterations, right? We have discussed all the iterations, so it was somewhat lengthier, that's it. So now query processing is easy, query processing is easy, right? So here we have the four queries, right? So we have four queries. This one I'm speaking of 1 2 2 4 2 5 2 6, 1 2 2 4 2 5 and 2 6, right? So let's move on with the same thing. So here let me go with Just give me a second here. So first query is 1 2, right? So query 1 consists of the 1 2. So what we will do, we will push the domino 1. See here, we have 1 and 2, right? So we will be pushing the domino 1 to the index 0, and we want index 1 to fall because we have 2 1 comma 2 we have. So this is at the index 0, this is at index 1, right? Index 0, index 1. The value 2 is present at the index 1, the value 1 is present at the index 0. So accordingly with the question, what we need to find, we need to find the maximum height, or the height that is required, the amount of height that is required for the x domino, x domino, x of j, or xth domino to fall, so that yth domino also falls, yth domino also falls, right? So here we want this one index 0, we have index 0 nothing but the value 1 to fall, so that index 1 to fall as well. So we will be making use of the binary lift here, we will be making use of the binary lift. As I have said, we will be going with a segment tree greedy approach as well as the binary uplifting, right? So we will be going with the binary lift from 0, binary lift from 0. This is nothing but the paradigm of 0 0, nothing but n here. No lift, no lift is required, right? So we are going with a binary lift from 0. This is nothing but, we can consider this one as paradigm of this one 0 0, nothing but n, nothing but n, no lift here, right? So since 1 falls when 0 falls, since 1 falls when 0 falls, we can just go with result of 0 minus result of 1, nothing but here in this case we have already pre-processed, we have already pre-processed certain values. So result of this one, what do we call, we have 2 2 2 1 1 0, right? Result of 0 is nothing but here 2, result of 1 is also 2, result of 0 1 2 3 4 5, right? So result of 0 we have the value 2, and result of 1 also we have the value 2, 2 minus 2 will give us the 0. So output for the first query we have got here 0, output for the first query we have got big 0 here. Next let's move on with the query 2. For the query 2 we have 2 comma 4, 2 comma 4, right? So we have to push the domino, nothing but the index 1 want the domino 4, want the domino 4 to fall. So this is nothing but the index 1, this falls under index 1, right? So this is index 1, uh, this is index 3, index 3, because index starts from the 0, right? So here 2 comma 4 is nothing but index 1 comma index 4, right? So index 1 comma index 3, sorry, index 1, this 4 is nothing but the index 3, right? Indexing starts from the 0, 0 based indexing. So we just have to go with the minus 1 here. So for the index this one, for this particular number we have to go with a 2 minus 1, nothing but index 1, and for this one, for the value 4 we have to go with the previous index, this one 4 minus 1, nothing but the index 3 here, right? We have to push the domino, nothing but index 1, we want domino 4, nothing but index 3 to fall, right? So we have to push the value 2 so that the value 4 falls here in the simple terms accordingly with the question. So this one will be paradigm of 0 1, that is nothing but 2, that is nothing but 2, and paradigm of 0 2, that is nothing but 3, that is nothing but 3. So now we are at 3, now we are at 3, right? So we will check 3 is less than or equal to 3. Yes, 3 is equivalent to 3, 3 is equivalent to 3, so this is valid. So what we will do, we will go with the result of 1 minus result of 3, result of 1 minus result of 3. So let's check result of 1 minus result of 3. Again I'll write, we have the pre-processed value 2 1 triple two double one zero, right? So result of 1 0 1 2 3 4 5, result of 1 is nothing but 2, result of 3 is nothing but 1 here. We will be going with 2 minus 1, 2 minus 1, nothing but 1. So the for the second query we have got the output 1 here. For the first query we had got output 0, for the second query we have got output 1, right? Let's move on with the third query. We have 2 comma 5, we have 2 comma 5 here. We will be this one index 1, this one index 4, this one index 4, we will start from 1. So paradigm same thing, we will carry on with the same steps that we did for the query 2 and query 1, right? So we'll go with a paradigm of 0 1 nothing but 2, paradigm of 0 2 nothing but 3, paradigm of 0 3. Again, because we are considering 5, right? So we have to go with the 3 and 4. So we have reached 4 here. We have reached 4 here. Paradigm of 0 1 equals 2 basically, and 2 3 4. Paradigm of 0 1 0 2 0 3 0 4, because we have to go from index 1 to index 4. We have to go from index 1 to index 4 here, right? So we have the value 2 3 4. We have successfully reached 4, right? So we will check 4 is less than or equal to 4. Yes, 4 is equivalent to 4. 4 is equivalent to 4. So we will be going with the result of 1 minus result of 4. So as we are dealing with the index, we will be going with the, so this is nothing but the zero based index. This falls to the index 1 and this falls to the index 4. Nothing but 2 minus 1, 5 minus 1 we are doing, right? So indexing starts from 0. So result of 1 minus result of 4. Again, we have the value 222 pre-processing. So this is 0 1 2 3 4 5 indexing, right? So result of 1 is nothing but 2 here. Result of 4 is nothing but 1 here. 2 minus 1 will lead us to the output 1. 2 minus 1 will give us 1 basically. Now for the query 1 we got 1. For the query 2 we got 0. For the query 2 we got 0. For the query 3 we got 1. Sorry, did I get confused here? Yeah, for the query 1 we got 0, for the query 2 we got 1, for the query 3 we got 1. Sorry. So for the query 1 we got 0, for the query 2 we got 1, for the query 3 now just now we got 1. We got 1. Let's move on with the last query, nothing but query 4. Query 4. So again we'll start from 1. For the query 4, what we have here? Mm, we have 2 comma 6, right? So just give me a second here. Yeah, we have got 2 comma 6, nothing but the index 1 and index 5, nothing but index 1 and index 5 here. So we'll start from 1 again. So we will go from we have to go from 1 to 5, right? Index we have to go from 1 to 5. So 1 to 5 means the fifth one will not be considering. We will be considering 1 2 3 and 4. We will be considering 1 2 3 4. So 4 is at the index 4. So here 4 is at the index 4, right? So but paradigm of 0 comma 4 is 5. Paradigm of 0 comma 4 is 5, right? So paradigm of 0 comma 4 is 5. So here we will go with the next jump, nothing but 5. We have domino 6 here, domino 6 here, right? So now what we will do, as we have to go from the index 1 to 5, we have to consider the last index 5, and the value that we got here is paradigm of 0 comma 4 is 5. We will check 5 is less than or equal to 5 or not. Yes, 5 is equivalent to 5. Again, 5 is equivalent to 5, right? So we are done with this one. We are done with this part basically, right? So now we have to go with 1 and 5 are the index we got here. We have to go with result 1 minus result of 5. Result 1 minus result of 5. Again, pre-processing 1 1 0, right? So this is 0 1 2 3 4 5, right? So here we are going with 1 nothing, result of 1 nothing but the value 2, and the result of 5 nothing but the value 0. Here we will be going with the 2 minus 0, nothing but the answer will be 2 itself, right? So the answer that we got for the query 4 is 2. So for the first query we got answer 0, for the second query we got answer 1, for the third query we got answer 1 again, for the uh, third this one fourth query we got answer 2. So overall answer we got here is 0 double 1 2, 0 double 1 2. So the output that we got here is 0 double 1 2, which is equivalent to the output that they have given for the this one first example, which is equivalent to the output that they have given for the example 1 within the question, example 1 within the question. So our approach works absolutely correct in this case, right? So in simple terms, the main thing is pre-processing. Main thing is pre-processing. After that one, query processing is easy, man. Query processing is easy. Already we have went with the pre-processing. All we have to do is check with the paradigm, right? So all we have to do is check with the paradigm, and finally we have to go with the subtraction, right? Accordingly with the queries. If we had queries 1 comma 4, then this will be from 0 to 3 index, right? So this will be result of 0 minus result of 3. That's what we did, right? So that's what we did. Query processing is easy. The first one, the first step mainly, the first 7 steps, we went with the this one pre-processing, right? So after going with the pre-processing, so now we had some values, triple two double one zero. That will be very helpful in the query processing as well. That will be very helpful in the query processing as well. So in the query processing, we made use of the binary uplifting, and for the pre-processing, we will be making use of the segment tree. So and segment tree, and for the query processing, we'll be going with the greedy along with the binary lifting. Overall, the this one, what do we call? Overall, the approach that we'll be going with here is segment tree pre-processing. Sorry, segment tree binary uplifting along with greedy approach, along with the greedy approach, right? So the output that we got here is 0112, which is equivalent to the output that they have given for the example one. So our approach works absolutely correct, and we are completely familiar with the approach, right? So first we went with the pre-processing. Second part is we went with the binary uplifting along with the greedy, binary lifting or binary uplifting along with the greedy. So the final step here is, let's discuss the complexities and then let's write the code, right? So what will be the time complexity here? The time complexity would be because of n log n plus q log n, n log n plus q log n, because here segment tree for the cost will lead us to log n. And for the query, we are also going with the query processing. We are going with the query processing from the step 8, if you remember, right? So segment tree, it's just login will give us the this one will lead to the time complexity login, and we are going with the query processing. So this will be q login. And one more thing we need to observe here is we are going with the binary lifting setup as well. As I have said, from the step 8 in the each query, along with the within the query processing, we are going with the binary uplifting as well, right? Or binary lifting, right? So again, for the each query, it will be logarithmic n, as we went with the pre-processing or the segment tree. We'll be making use of the segment tree for it, and we will be going with the n binary lifting, right? So n will be going for the n queries, basically for the binary lifting. So this will lead to n log n plus q log n, n log n plus q log n. So overall time complexity would lead to big of n log n plus q log n, n log n plus q log n. So what will be the space complexity here? Space complexity would be big of n log n, big of n log n, because for the parent table, so we'll be making use of the parent table, right? So we'll be making use of the pre-processing or the parent table, and we'll be going with the result array. We have to store the result somewhere, so we'll be making use of the result array. And also we will be going with the segment tree storage, and also we'll be going with the segment tree storage. So overall space complexity would lead to big O of n log n. Overall space complexity would lead to big O of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n log n plus q log n and big of n log n respectively, right? So now we are done with the complexities and the approach part. As we are done with the complexities and the approach part, we are good to write the code. Let's start writing the code. Now let's start writing the code. Here, so we'll be making use of the fast input and fast output along with the utilities, different utilities, right? So let's import the input output package and the utility package. So I'll just go with import, sorry, yeah, import java dot input output dot star. This is fine. Import java dot util dot star. Sorry, this is star. This is fine. The next step is I'll just go with a class named main. So you can just go with any name. So I'll just go with main. So I can just give the question name itself or any relevant name, right? So this is fine. The next step would be we have to define the constants, right? So maximum number of dominoes that is allowed accordingly with the constraints they have given in the input output within the question is 2 into 10 to the power of 5. So let me go with static final here int int n equals 2 into 10 to the power of 5, right? So I can just give here 4 zeros and 5, right? So this is fine. The next step is let me go with the static final int. So let me go with the lg equals 22. So why I have given 22 here? The maximum log for binary lifting is 2 to the power of 22. Nothing but it has to be greater than 2e5, right? 2 into 10 to the power of 5 basically. Maximum log for the binary lifting, we are making use of the binary lifting. If you remember the approach, we are going with the binary lifting, right? So maximum log for the binary lifting is 2 to the power of 22, which is greater than 2 into 10 to the power of 5, right? So I hope this part is clear why we have considered this, the number 22. Next, we have to go with a large constant used as an infinity. So here I'll just go with, sorry, we have to go with a large constant, right? So let me go with static final. So this one int infinity, this one equals, so int 2 into 10 to the power of 9. So this will be, I'll just give 2e9 here, 2e9. We are just going with a large constant used as an infinity, right? So next, let's go with all the arrays that we will be making use of. So here we will be going with the arrays for the position, length, result cost, and also the jump pointers. Also the pointers, these four things, right? So arrays for position, length, this we know, position and length from the input itself, right? Array for the position and length. Also we have to go with the result cost, right? We have to store the result cost somewhere, and also the jump pointers. These four arrays will be making use of. First, let's go with the position of each domino. Here this will be static int, so p, this will be new int of capital N, this is fine. Next, static, so this one will be int, I'll just go with value lval equals new int, this one is n, right? So next again I'll just go with static int, uh, this one will be result equals, so this one is new int of uh, n n, so this is fine. The final one here would be static, so this one will be int again, so this one I'll just go with a paradigm. So this one will be new uh paradigm new, I'll just give here int of, so log I have considered lg, right? So if you see here, this one we are considering log, this one lg we have considered. And one more thing, we'll be going with the n, capital N. This is nothing but binary lifting parent table. For the binary lifting parent table, we are making use of this array, right? So first one is for the position of each domino. The second one, line number 11, this is for length of each domino. The third one is result of I. This is nothing but minimum cost from I to n. The final one is binary lifting parent table, right? So now let's do one thing. I don't want to write this one basically. This is just the input output part. So I will be making use of the custom fast input class using buffered stream. So this is purely related to the input output. I'll just copy paste the custom fast input class. So we will be going with the custom fast input class using the buffered stream, right? So let me come here. So let me paste it over here, right? So this is just the pure, this is related to the input output part. This is nothing but the custom fast input class using the buffered stream. As the constraints are very tight, we are making use of this thing. What do we call? We are making use of the custom fast input class using the buffered stream, right? So I have several templates basically which I make use of basically for the this one contest, right? So usually I go with the buffered input and the this one, what do we call, uh, buffered input and I mean buffered stream reader as well as the print writer, right? Or the buffered reader and the print writer, usually, right? So or else uh, there are many templates, man. I don't want to discuss about the templates. So here this is we just need to know that this is custom fast input class using the buffer stream. This is just related to the input output. Let's ignore this one, right, for now. Now let's move on with the main logic, nothing but the segment tree part here. So we will be going with the segment tree for maintaining the minimum cost efficiently, right? So I'll just go with the static class. So let me go with the segment tree, right? Segment tree. So within the segment tree class, so let's go with the segment tree array first. I'll just go with long tree, as well as we have to go with the size of the segment tree as well. So let me go with the int size. So the next step would be, let's go with the initialization or the constructor part, right? So I'll just go with the segment tree here. I'll just go with the parameter and what are the things that we need to initialize here? Size. Let me initialize this one to n. Tree, let me give here new long of this one, 4 into n. This is nothing but the we are allocating memory, right? So here we are considering 4 into n, right? So also we have to initialize with the infinity, right? So I'll just go with arrays dot fill of tree. We are initializing with the infinity, right? So I'll just go with long dot max underscore value. So this will be long dot max underscore value. So let me come out of this one. Now let's go with the point update in the segment tree, nothing but the recursive or the recursion, right? So we are going with the point update in the segment tree, nothing but we are going with a update method here. Usually we are going with a update method, so we will be making use of query and update. Usually whenever we write the segment tree, we are making use of the segment tree, we go with three methods. Usually we can we might not consider any one or any two, or we might not consider this one. For the particular problem, we might not consider one or two, but usually we write three this thing. Usually we go with the three methods. One is build, first one is build, another one is query, and the third one is this one, update, right? Now first let's go with the, for this particular problem we'll be going with the update as well as the query. Update because we want to point update in the segment tree. For that we'll be making use of the recursion, or it is recursive. And the next one is for the query, we will be going with the query, this one method, because we have to go with the range minimum query. So these two methods we'll be making use of, along with the public update and query methods as well, right? So just give me a second here. So I'll give here void update. So what are the parameters I'll consider here? I need index. Let me go with the index. I need value. I'll just go with the val. So let me go with node here. This is fine. I also need left and right. Int left, int right. This is fine. I hope this part is clear, man. Within the update method first, so we have to update the leaf. We have to update the leaf node, right? So if left value of the left is equal to right value of the right, then what we need to do, we need to update the leaf node, nothing but here tree node equals val. This is fine. We don't have to return anything, so I'll just give return here. We don't have to return anything. I'll just give return here. This is fine. We have to calculate mid. I'll just go with int mid equals left plus right by 2. This is fine if index less than or equal to mid. If index less than or equal to mid, then let's go with the left child. If index is greater than or equal to mid, we have to go with the right child, and then we have to merge the step. Right? First, if the index is less than or equal to mid, let's do one thing. We are going with the binary search here, right? So basically, I'll just go with the update the parameters here, index val node into 2 left comma mid, right? So we are going with the left child. Else what we need to do, we have to go with the right child. So let me copy the same thing and make the necessary changes. So here let me copy this one, paste it over here. So this one is index value remains same, So instead of node into 2, we have to move from left to right. The next node, this will be node into 2 plus 1, and this one will be here mid plus 1, mid plus 1 along with the left. So we don't need this mid at the end, right? So along so we are going with the right side, right child, right? So I have to mention right instead of left. Next we have to merge the step, we have to merge the step, right? So now for merging, I'll just go with tree node, tree node equals math.min. So this one will be math.min of tree node into 2, node into 2 comma tree of node into 2 plus 1, node into 2 plus 1. So we have successfully merged step here. So let me come out of this one entirely. Now what I'll do now, just give me a second here. Yeah, let's move on with the query method, right? So I'll just go with a long query here. So the parameters we'll be making use of here as left. For left I'll consider L, for the right I'll consider R. So for the node I'll be going with node itself. Also another left and right completely I'll consider left and right. So this is fine. So first, if there is overlap, then we have to return the maximum value, right? Maximum value. So here, if R less than left or right less than left, this one L, then we need to return long max underscore value. So this is fine when there is no overlap. So we have to go with three things usually within the query. Usually we have to go with when there is a overlap, when there is no overlap, and when there is partial overlap. These three things, right? The first condition we went with here is in the line number 65, when there is no overlap. Now we are going with the total overlap when there is overlap, complete overlap or the total overlap. So this will be if L less than or equal to left and uh, this one right, right less than or equal to R, less than or equal to R, then I'll just return tree of node. So tree of node, this is fine. This is for the total overlap. Then let me go with mid equals left plus right plus right by 2, left plus right by 2. This is fine. So now again, let me go with the return, return, here return math.min, math.min, math.min query. So this one is L comma R comma node into node into 2 comma left comma mid, left comma mid. This is fine. So the next step is again let me copy the same thing here, copy the same thing here. So let me paste it over here. This is fine. This one will be node into 2 plus 1 for the right. Instead of left here, we have to give, mm, let me go with mid plus 1 and this one is right, right. So I'll just go with the right. This is fine. Instead of the comma, so I'll not go with anything here. So we are writing this one within the math.1, right? So here I'll go with semicolon. This is fine. This one mid plus 1 and right. So this one is fine. This is for the partial overlap basically, right? So let me come out of this one entirely. Now let's go with a public method to update the index and also public method to query range, right? So this is end of the segmentary class. This will be end of the segmentary class after writing the public method to update index and query range. So here let me go with void update quickly. So the parameters I'll consider here index as well as value. So this is fine. So here this will be update. So this one will be index comma value comma 1 comma 0 comma size minus 1. So this is fine. Let me come out of this one entirely. So let me copy the same thing and make the necessary change for the this one query. So this one will be query. So the parameters I'll be considering here would be left and right. So this one will be int L. So this one, instead of long value, I'll be going with int R. So here instead of update, let me go with query. So what are the parameters I'll be going with? So here, oh, I didn't write return here. So for updating, we don't have to return, right? So we are just updating the value. So for the this one query, we need to return, right? So we have to go with the return query. So what are the parameters here? So just give me a second here. So left, comma right, comma 1, comma 0, comma size minus 1. So this is fine. So this is just the public method to query range, right? So I'll just come out of this one entirely. So next what I'll do, let's go with the solve or the main method basically, right? So within the main method, let's give the solve method first. Let's make use of the helper method solve here. So here this itself is the main method. We will be giving this one within the main method, right? So I'll just go with public static void solve. Mm, let's go with throws input output exception. So this is fine, man. So within this method, what shall we do? Uh, First, let's go with a fast input reader. So here we have made use of the fast input reader, right? Fast scanner. So let me copy this one entirely. So let me come here. So let me paste it over here. Fast scanner. So I'll just go with a cn new fast scanner, right? So this is fine. After going with the fast input reader, so we have to read the number of dominoes as well. For that, I'll just consider n equals cn dot let's go with the next int itself. Let's go with the next int, right? So next, let's go with the iteration part here. For int I equals 0, I less than n, let's increment the I. So within the for loop, let's read the exposition first. Let's read the exposition, right? First, right? Iterated value of the p equals cn dot next int. So this is fine. The next thing is here lval equals, so this one is cn dot next int again, right? So here the line number 88 and 89, what we are doing, we are reading the exposition, also we are reading the length, right, in the line number 89. So let me come out of this one entirely. Let me come out of the for loop entirely. Now we have to within the step 8, if you remember, in the approach we went with the binary lifting, right? So now let's initialize the binary lifting jump table to n, nothing but out of bound, right? So I'll just go with one more iteration here, for loop. So I'll just consider j equals 0, j less than log value we have considered 22, nothing but j less than lg here, and also j plus plus. So this is fine. I'll just go with arrays dot fill. So paradigm of this one, j comma n, j comma n. So this is fine. Let me come out of this for loop entirely. Now I'll be making use of the monotonic stack here, right? So let's make use of the monotonic stack just to track the chain of fall, just to track the chain of fall, right? So I'll just go with instead of the standard stack, I'll just go with the dq for this one, right? So integer, so this, sorry, just give me a second here. Yeah, dq of integer. So let me go with the stack and let me send this one to new array dq, right? So this is fine. New array dq, this is fine. So we went with the monotonic stack to track chain of fall, right? So next, let's go with the last domino that needs zero cost to fall, this one will be result of n minus 1 equals 0. This is fine. Next, we will start from the last domino. Nothing but stack dot push of n minus 1. So this is fine. The next step would be, we have already written the segment tree class. Let's build the segment tree of size n, right? So this is simple segment tree. So I'll just go with s tree here. S tree, nothing but the segment tree. So this one will be new segment tree. We are building the segment tree of size n, right? So let's pass n here. So this is fine. So now let's update the last domino cost. We have already written the update method within the segment tree class. So I'll just go with a variable s tree here dot update. So here this one I'm speaking of, we have already written the update method, right? So let me copy this one here. Let me paste it over here. Segment tree dot update. So this one from 0 to n minus 1, right? So n minus 1, 0. So we're just updating the last domino cost, right? So this is fine. Mm, 1 second. Domino. So yeah, this is fine. Let me let's do one thing. Yeah, let's move on with the further things, man. We have to process from right to left here. We have to process from right to left. If you remember the iteration, so I went with I equals 5, domino 6, I equals 4, uh, domino 5, I equals 3, domino 4, like that we went, right? So reverse iteration. So while explaining the approach, I said the same thing. We'll be going with the reverse iteration. So whatever we have discussed in the approach, the same thing we are articulating in the form of code, basically articulating in the form of code, right? So now let's process from right to left to compute the minimum cost for each domino, right? Let's carry on with the, or let's move on with the iteration part here. This one will be int I equals n minus 2, I greater than or equal to 0. So this one will be I minus minus. So let's initialize with infinity first. So I'll just go with the iterated value of the result equals infinity inf. This is Java, right? Yeah, inf. This is fine. Now what we need to do, we have to pop all the dominoes that is reachable by current dominoes fall. So I'll just go with here, while stack is not empty, nothing but stack dot, I'll just go with the is empty operation that is provided by the stack is empty. And so iterated value of the p here, this one, so this one is l val of I, if it is greater than or equal to p of uh, stack dot peak here. So then what we will do, so within the while loop, we j is reachable domino. Then if it is greater than or equal to stack.peak, then it is a reachable domino, right? So in our case, if you remember the value when we went with the query, right? So we went with this one, what do we call 3 less than or equal to 3, 4 less than or equal to 4 every time for the query, right? That step, if you remember, that step itself we are articulating in the form of code. Now if it is reachable, how can we j is reachable domino, now how can I write that one in the form of code? I'll just give here j equals, we just need to pop, right? So I'll just go with a pop, stack dot pop, and we have to take the minimum cost from the j, right? So then we went with a result of index, right? Something 1 minus a result of 4, result of 2 minus result of 4, accordingly with the query numbers they have given, accordingly with the query, basically, right? So I'll just go with the result of I equals math.min. We have to take the minimum cost from the j, right? So this will be result of j, result of sorry, this has to be result of I comma result of j. So this is fine, man. Result of I comma result of j. Yeah, let me come out of this one entirely. So now let's do one thing. If there is a domino, if there is a domino that is not yet reachable, then we have to calculate the extra cost that is needed. Let's go with a simple if condition here. So this will be stack dot is empty, stack dot is empty. This is fine. Within the if condition, we will go with the closest unreachable domino, nothing but int j equals stack dot peak, stack dot peak. This is fine. So this is the closest unreachable domino. Next, we have to go with the required extra length, nothing but here I'll just go with gap and assign this one to p of j, p of j minus, so this one will be p of i, p of i plus lval, lval of I. So this is fine. So we went with the required extra length that is needed. So this is fine. Also, we have to add the cost from j and store the 2 to the power of 0th jump. 2 to the power of 0th jump, even I don't know why we are using it here. So we are just going with the first forward reachable. First forward reachable. I don't know whether it is required or not. First, let's add the cost from j. So I'll just go with iterated value of the result. This is equal to math.min, this one iterated value of the result, comma gap plus result of j, plus result of j. Next, this step we have to store the 2 to the power of 0th jump, nothing but the first forward reachable. I don't know why we are making use of here this one man. So I'll just go with 0i equals j. This is fine, is fine. Let me come out of this one entirely, if condition. So next step is this we know. We have to build the binary lifting table, nothing but 2 to the power of jth parent from the I. Let's write the simple for loop here, again the iteration part. So this will be int j equals 1, uh, j less than lg, and j plus plus j plus plus. So if bar, so this one is j minus 1, again I, then what we need to do, if it is not equal to n, if it is not equal to n, then let me go with bar j, paradigm j I, this one equals par j minus 1. So this one again, this one will be of j minus 1 I, right? So this is fine. This one. Let me come out of this one entirely, man. Let me come out of this one entirely. So this one will be is segment tree dot update, segment tree dot update I dot result of I, result of I. So this is fine. We are just updating the segment tree with minimum cost at I. Also, we need to push I to the stack for next iteration. Nothing but stack dot push, stack dot push of I, stack dot push of I. This is fine. We are just pushing the I to the stack for next iteration. So let me come out of this one entirely. What we need to do here, we need to read the number of queries first. So this will be int q equals cin dot next int. So this is fine. The next step is this will be string builder. This one will be string builder. I'll be making use of the string builder, variable name is b. So I'll just go with a new string builder. So we are making use of the string builder just to store the output, man. First thing, the line number 128 is q variable whatever I have used. So that is for reading the number of queries. String builder, I have made use of the string builder just to store the input, right? So let's move on with the further things here. Let's move on with the further things. So this is input output, but basically let me write this one quickly. So decrement, if it is greater than 0, so int l equals cn dot, this one will be next int, this is fine, minus 1, nothing but we are converting to 0 based index here. So this one will be r equals cn dot next int, so this one minus 1, right? So let's start from x. So I'll just go with x. Let me assign this one to l, nothing but we are starting from the x, right? So next step is we have to jump as far right as we can without passing yj, without passing by j. We know this one. So let's go with one more iteration part here, for loop. So this one will be int j equals log lg. 22 we have given value if you remember. So this one lg minus 1, reverse iteration, j greater than or equal to 0, this is fine, and j minus minus, so this is fine. Within the for loop we have to binary jump forward. If you would have paid attention to the this one, what do we call, uh, approach binary lifting part, this would be easier, right? So this will be if paradigm of j x is less than or equal to r, then what we need to do, x, let me assign this one to the paradigm of j and also x, j and also x, right? So we are just binary jumping forward. Next, we have made use of the string builder to store the output. So let's do one thing. We know this cost is nothing but the result of left minus result of x. That itself I said earlier, right? So we went with result of 1 minus result of 3 and all, right? Within the queries at the end, accordingly with the query numbers that they have given in the input, right? So accordingly with the index we went. So here we are going with the cost equals result of L minus result of X, if you remember the approach correctly. So this will be string builder dot, I'll just go with the append. So this one will be result of L minus result of X, So let's go with the append. So this one will be slash n. This one will be slash n, right? So this is fine. Let me come out of this one entirely. So we have to output all the query results at once, right? So I'll just go with the system out println. So here within this compiler, we have to give println for system out println. So this one will be SP. So this is fine. This is it for the code. Next, what we need to do, so I'll just go with the main here. We go with the main method. So here I'll just give throws input output exception. We have already made use of the input output exception here. So let me copy this one entirely. Let me copy this one. Let me come here. So let me paste it over here. Throws input output exception. So let's call the main logic here. Main logic, whatever where we have written within the solve, right? So I'll just come here. Let me copy the solve method here. Let's call the main logic within the main method. So I'll just go with solve, right? So we are done with the code. So before checking the code with different what do you call, different inputs, I just want to copy paste the signature starter template, right? So just give me a second here. So I'll just come here. Let me paste it over here. Let's concentrate on the logic part, man. So I'll just come to the question here. Yeah, let me copy this one. The output that we need to get here is 0 1 1 2, right? So here let me paste the input. So let me run this one. We are having the error. Line number 97. Let me come to the line number 97, where it is within the query, right? So we have given void query, right? So here we are going with a public update and public query. So this for the update we have made use of the void. For the query we have to go with the long, right? So here this is fine. This is the reason we are getting the error, I think. So we have one error in the line number 107. Yeah, that error is gone. Fine. Mm, L equals seen. What is the error we are getting here? Incompatible types. Int cannot be converted to int of array. So here, so yeah, here int cannot be converted to int because we are not making use of this has to be iterated value of the L right? So I have not used I within the array. So that is the reason we are getting the error, I think. So here, let me run this one. Yeah, now we are getting the output 0 1 1 2. Yeah, that was the error basically, right? So now what we have done here basically, three things we are doing here. One thing, we have made use of the segment tree. We are making use of the segment tree for the pre-processing, and then we are going with a greedy approach as well. Within the solve we are going with a greedy approach as well. So this one, yeah, we are going with a greedy approach along with the binary lifting. We are going with a binary lifting as well. We are going with a binary lifting as well. These are the three methods that we are, these are the three approaches that we are going with. Mainly, this problem we are solving with a segment tree. We are solving with a segment tree. For the mainly we are using the segment tree for the pre-processing purpose, right? So as the constraints are very tight, we are just going with a pre-processing. For the pre-processing, we are making use of the segment tree. We are making use of the segment tree, right? So I hope the solution part is completely clear, man. I hope the solution part is completely clear. So let me copy this one. Let me come here. Let me paste the code here. Let me hit the submit button. So I hope this works for all the test cases, man. Let's see. Let's see. Let's wait for some time. Here you can clearly see running on test one. Let's wait for some time. So yeah. So here you can clearly see. And the toast we are getting accepted, and also here the verdict we got accepted, right? So that means whatever the code that we have written works absolutely correct for all the test cases, absolutely correct for all the test cases, right? So yeah. Mm, so this is fine. Yeah, so I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.